Well, hello, folks. Welcome to the lecture on Chapter 7, Survey Sampling and Inference. I think one of the first things I want to say is that one of the things that makes this particular textbook pretty unique is, in fact, this chapter. I've been teaching this topic for about 30 years, and frankly, this is the only textbook that I've seen that actually has a chapter on what is basically about polling. And so, in that sense, you can think of this as kind of the strength of the textbook. And you're going to learn some secrets about polling. So, let's get started. So, polling is basically using a survey to do a number of things, but primarily to figure out a percentage, right? We're typically interested in things like the percentage of people who will vote for a given candidate, say candidate X, or the percentage of people who listen to a certain genre of music, or a percentage of people who will purchase a particular product or service for that matter. Right? So generally, we're trying to figure out, what percentage of people will do something. The other piece to this that you may not oftentimes realize is that you're also trying to get some sense of how confident you are of the answer that you get. And generally, this is something that we derive after we've kind of figured out a confidence level. So some popular confidence levels that you see here is the 68%. You might recognize that from the empirical rule that was talked about in chapter 3. The 95th confidence level, right, suggests we want to be at least 95% confident, and then the 99. You'll notice that the 95th is red because actually that's the most typical confidence level, right? So most polls that you see generally choose a 95% confidence level, okay? And then we figure out something that gives us a sense of a range of possible scores, and that's done by finding something called the margin of error. Now, that's a term that you've likely heard of before, but perhaps didn't really understand what that meant. Well, this is the chapter where you're going to figure that out. In fact, most of the time when you hear about a margin of error, it's based around a 95% confidence level. All right. So one of the first things that the chapter deals with is this issue around survey terminology. And so there's some terminology here that you introduced that I want to kind of walk you through right quick. One is the idea of a population, right? So generally the population is the group of people or objects that you're basically interested in studying. For example, as a psychologist, because our theories are designed to explain people in general, our population is basically all 7+ billion people on the planet, right? Because that's the group of people, right, that we want our theories to be applicable to. Okay? A parameter then is some kind of numerical value that characterizes some aspect of that population. So, for example, if I were trying to calculate some of the statistics that we've talked about before, like a mean or a median or a standard deviation or interquartile range on all 7+ billion people on the planet, that would be an example of a parameter, okay, because it pertains to the population. A census is really an attempt to survey virtually every member of the population. So, for example, in the United States, every 10 years, we have a census. And it really is an attempt to literally count every person in the U.S. So we have about 350 million people in the U.S. And so the idea of the census is to account for all those people. Okay, so all of these things really sort of pertain to the population, but oftentimes we can't get at that population, right? There's no way on Earth I'm going to ever have either the time or the resources to try to study 7+ billion people. So oftentimes in my survey methodology, I'm having to settle for a subset of that population, and that's something we call a sample. Okay, and so it's a subset of the population that you're interested in, and on that sample, right, when you're calculating things like means and medians and standard deviations, those are actually called statistics. So hopefully you can see the parallel now between, say, samples and populations, and just as important, between parameters and statistics. They are essentially the same thing. They're just called something different depending upon who the target is, right? So when I'm calculating the mean of a population, we call that a parameter. But I'm calculating the mean of a sample, we call that a statistic. Let's look at an example. So A survey asked 1,000 U.S. college students if they preferred to study alone or with others. Okay, and virtually 420 people answered in the affirmative that they preferred to study alone. Okay, so just based upon that, right, we have a sense of what our percentage is. We're talking roughly about 42%, right? And I calculated that just off the top of my head by dividing 420 by 1,000. Okay. Uh, and so, what's our population in this case? Well, the population would be all U.S. college students, right? Because ultimately, what I'm interested in is, what percentage of college students prefer to study alone. I'm not just interested in this group of 1,000 people that we have. Okay, the sample, though, is this group that I have, right? So I went into the population of college students and extracted out of that population a sample of about 1,000 students. A parameter of interest. Now, the interesting thing is that the parameter really is our goal, okay? Because, sure, 420 people out of 1,000 is interesting, but that really only tells me about that 1,000 people. But I want to know about all college students in the U.S., okay? So the parameter that I'm interested in is, in fact, all college students. I want to know what percentage of all college students prefer to study alone or in some cases with others, okay? But the statistic that I have based upon this sample, right, has a proportion of 0.42. And by the way, proportions are just other ways of expressing percentiles, right? It's kind of hard to do mathematics with percentiles, so we normally just simply leave them as proportions. And we work with the proportions until we're done, and then we just sort of convert them back to percentiles, right? And just remember, that's just a factor of moving the decimal place to the right two places, right? So that 0.42 basically becomes 42% when I move the decimal to the right couple places, okay? And so the inference, the leap that we're trying to say, right, based upon this sample of 42%, right, I'm trying to essentially say that 42% of all U.S. college students prefer to study alone. Okay. All right. So we talked about this idea of finding the percentile. Okay. And that's what we just did. But the other piece to this is finding the confidence. Okay. So we're going to talk about how these things kind of work together. Now, what you see here are really two different formulas. On the left is really the idea. Remember mu, we talked about that in chapter 3. That's just the Greek symbol for the mean of a population, right? So basically that would be X bar, right? X bar is for samples, mu's are for population, but it means the same thing. But in this case, we're dealing with percentages, right? So all this is basically saying is, hey, what we ordinarily would look for in terms of a mean, we're finding it in terms of the percentile. Okay, so not really a formula, just sort of a conversion notion here. But what we see over here is the sigma, okay? And remember, sigma is like our S. Our S represented our standard deviation, okay? And sigma represents that. But since we're talking about percentages and proportions, we're actually really dealing with something called the standard error. It's interpreted very much like a standard deviation, but it's slightly different, right? And I'll leave it to your chapter to kind of explain that. You don't really have to know the difference that much at this point, okay? But there's a formula for calculating that. And so it says the way that we find the standard error is going to be equal to the square root. Remember, that's what you see here. The proportion, which will be the same number that we have here, going to be multiplied within the parentheses, which means do this first, is 1 minus that same proportion, okay? And then remember, any number next to a parentheses means you're going to multiply it. Okay, and then you're going to divide it by n. And once again, remember, n represents sample size. In terms of order of operations, right, you remember this from your algebra class, what you'll want to do is do this stuff up here, right? So the way I would actually do this equation is I would go 1 minus the proportion, okay, multiplied by the proportion, okay, then take that product, divide it by n, okay, and then take that and take the square root of it, okay, and that would give me the standard error. All right. And so, like I said, the first point is that the mean of sampling distribution is equal to the population proportion. And so one of the things you can see is the importance of sample size here. Okay, the larger your sample size, ultimately the smaller the standard error becomes. Okay, and that's important to remember, for some other things that you'll kind of talk about. But so sample size matters a bit here. In your chapter, for example, it talks about the central limit theorem. And that's kind of the main point of that central limit theorem. Just wanted to point that out, but not all that important for what we're doing right now. Okay, so if that's how you find the proportion and the standard error, then the issue is now how do we use this information and find this confidence? Remember, those are our 2 points. In polling, we want to find the percentage, right? And then second, we want to find the confidence. Well, we're going to use that information to do so, right? So the first thing that we need is we're going to need that proportion and the standard error, okay? Sometimes that's given to you, and then you can just work from there. Other times you're going to need to actually calculate that based upon the data, right? Either way, you can actually figure that out. That formula is pretty easy. This is the one chapter where you actually probably would work faster just whipping out a calculator and actually calculating that formula, even though at the end of this lecture, I'm actually going to show you how to calculate that using StatCrunch, okay? All right. So the other thing is once you have your proportion and your standard error, you're going to need to find the margin of error. Now, the emphasis on finding the margin of error is the fact that it's not something that you calculate, right? You're going to find this. And you're going to find it by, number one, first deciding what level of confidence, right? Remember, we talked about that 68%, 95%, 99%. Most of the time in life, you're just going to use the 95%. But since this is a stats course, there are going to be times in which you're going to be doing homework that's going to ask you to choose some different kind of confidence level, okay? Once you know what your confidence level is, right, then there's a table that's provided both in your textbook, but I'm also going to provide it to you here in a minute, that you can use to look it up. That would be this table here. Okay, so generally, if the confidence level, let's say it's 95%, then there's something called the multiplier here, which is 1.96. Now, this is always true, okay? So once again, there's nothing we calculated. If we choose a 95%, it doesn't matter what your problem is, right? Your multiplier is always going to be 1.96. Okay, if you're looking at a 99% confidence interval, then your multiplier is going to be a 2.58. Once again, it's given it, like pi equals 3.14. Notice we didn't calculate that, we looked that up. Okay, and so this is a table that's also found in your textbook. You might want to print out this PowerPoint slide or take a sticky note and put it into your textbook, because that's where you're going to find it. Okay? Or if you're really nerdy, you can memorize this. Never met anybody crazy enough to do that, but you're welcome to do so. Okay? All right, so we've done that. The next step that we're going to do here is we're going to then take that multiplier and we're going to multiply it to the standard error. Okay? And that's actually how you find the margin of error. So the margin of error is basically that multiplier, right? That number we just looked up, multiplied by the standard error. Okay. And then finally, right, because what we're interested in actually is finding a interval, which is basically another way of saying a range, right? To find, and of course a range is usually represented by two numbers, right? We're going to add the margin of error to the proportion to find the top number. Okay, and so that's going to give us the top number in our range. Once again, we're just going to add this margin of error that we just found here to the proportion, right, where we started with. And that's going to give us our top number. But then to find our bottom number, we're going to simply subtract the margin of error from proportion to find the bottom number. Okay, and it will be basically between those two numbers that gives us something called our confidence interval. Okay, so I'm going to stop part 1 and continue in part 2.